Welcome back, Algebra 1 folks. We are continuing our discussion on simplifying exponential expressions in this video with two more examples. So in this first question, Haley and Lacey have two different expressions. Haley has x cubed times x squared. So let's highlight that here. Oops. X squared times x cubed, and then got x to the fifth. Lacey has, I'll underline that one, x cubed plus x squared, but also got x to the fifth. What the heck happened? Are they both right? Are neither of them right? Is only one of them correct? Let's take a look at this. Well, we can think about what x to the fifth actually means. Remember, x to the fifth power just means you have 5 x's, 1, 2, 3, 4, 5, multiplied together. So x to the fifth really just means x, 2, 3, 4, 5. Okay, so let's think about which of these two expressions, x cubed times x squared or x cubed plus x squared, actually means x times x times x times x times x, right? So with Haley's, let's see, we have x cubed, which really means x times x times x, and x squared would be x times x. Therefore, I think we can kind of just substitute these in. X cubed times x squared really just means 1, 2, 3 x's. That's right there. Actually, let's just leave this out. Times x times x. Now, I could group them together like so with parentheses around here, just to make it really clear where those 3 x's came from at first, and then and then the 2 x's on the end. But remember, since it's all multiplying, it doesn't matter if you multiply these 3 first and then these 2, and then to multiply those answers. This is where we say that multiplication is associative, that it doesn't matter how you group them up. And so really, this just is the same as saying x times x times x times x times x, which is x to the fifth. So I absolutely think that Haley is correct. But let's take a look at what Lacey did. So Lacey, like we said here, has x cubed plus x squared. But if I substitute those in with what we saw over here, this would really mean x times x times x plus x times x. Now, is this the same as saying x times x times x times multiplied? I don't quite think so, right? And we can do this with an example if we really wanted to. Let's just pretend like, as an example, that x equals 3. So if I have 3 cubed plus 3 squared versus what Haley did, 3 cubed times 3 squared. We can see here, this is going to be, let's see, 3 cubed is actually 27, and then 3 squared is actually 9, which will leave us with a final answer of 36. Whereas over here, we have 27 times 9, which is, let me double check here. Well, that's beyond the point of the video. My mental math is struggling a little bit, but it's definitely not equal to 36. Right? So they're very different. And so we want to be really careful here. And so Lacey's actually not correct, unfortunately. Sorry, Lacey. But this is definitely something that I've seen students do and kind of get mixed up on all the time. And just remember what x to the fifth or x to whatever power actually means. It's all being multiplied together, and that's why you can group them up as x cubed, group up that x cubed and that x squared together into x to the fifth. And we're going to show in a later video this little shortcut and how you can kind of do it quickly. In this case, we would not consider these like terms. You might have heard that term before. Like, because they're not alike. One of them is x cubed and one of them is x squared. And so Haley is correct here and Lacey is not, unfortunately. Alrighty. Now let's take a look at this last problem here. It's another way of, or the question is another, did I simplify this correctly question. And so we have, let's write this down a little bit bigger. 3 to the fifth times 4 to the fifth equals 12 to the 10th. Is that correct or not? Well, let's take a look. I don't really want to evaluate these because I don't have my calculator on hand, but let's just think about what this would mean, right? On the right side, this would mean 12, 12, 12. Let's see, 1, 2, 3 of them. How many of them exactly? Would there be 10 12s multiplied together? Okay, so the question is, does the left side of that equation produce 10 12s multiplied together? Well, let's see, 3 to the 5th, that'd be 3, 3, 3, 3, 5 3s, times, I'm going to multiply these underneath in a funky way, kind of because I ran out of space, and 5 4s together. Okay, so I think you can kind of see where the 12 comes from, because again, multiplication is associative. It doesn't matter if you multiply all the 3's first, and then multiply each one of those by 4 times 4 times 4 5 more times. Or you can instead multiply each 3 with a 4. Multiply this 3 with a 4. And multiply all those then together. So let's do that here actually. So I'm going to group up each 3 with a 4. You can see here what's going to happen is that 3 times 4 is 12. So this is a 12, this is a 12, 12, 12, and 12. So I can see that's how Haley got the 12. Oops, excuse me. But what happened is, how many 12s are there actually? I don't count 10, I actually only count, 3, 4, 5 12s. So this is actually 12 to the 5th, which is not 10 to the 12th, unfortunately. So we can definitely see maybe what Haley was going for was that she saw the 3 and the 4 and multiplied them together, and I guess she saw the 5 and the 5 and added them together to get that 10. Unfortunately, it does not quite work out that way because each of those 3's, which there are only 5 of them, and there's only 5 4's to get paired up with, each one of those makes a 12. And so there's only 5 12's, not 10 of them. Alrighty? So hopefully this made a little bit more sense and helped us further our understanding of how we can simplify expressions involving exponents. See you in the next video.